let's talk about interactive visualizations. That's the for us who are interested in human-computer interaction, that's the key issue. Visualization without interaction is not very interesting, to be honest. Let's talk about interaction techniques, then about the taxonomy of different interactions, and in the end we can see some alternative interaction techniques. What we mean by interaction technique? You can have a data and a view specification. You can visualize, filter, sort, derive information. Then, as we have seen, the key aspects when you have non-trivial data is the ability to have many views and manipulate those views. That allows you to explore the data instead of just looking at something. And we can select, we can explore, we can reconfigure, we can encode, we can make it more abstract, more elaborate, we can filter out things, and we can connect things together. This sounds theoretically, and yes, it is, that's a taxonomy, but we are going to see a lot of concrete examples. This is actually what I'm going to deliver for you today. And I already emphasized that what we are doing here is a process. Non-trivial information visualization is a process, not a static thing. We need to record those, we need to annotate those, we need to share those, and we need to guide users, other people, how they find what they're looking for this set of visualizations that we have done. So, let's go now for the details, and let's start with the selections. So let's show the video. It explains where we are. This is a very typical hover and clicking interface. So you are basically browsing, exploring the visualization space by hovering your cursor over the items. You immediately see something displayed, and then you can click for the further information. This is actually pretty good example of which could be easily used in one of our projects as well, because it provides information about the nature. And as you can see, you have seen this like a visualization earlier already. And like I said earlier, many of these more complex or more interesting visualizations, they combine different viewpoints. So they are not just a presentation of any one. Then let's talk about how we can query something. Here's the video. We can select. We have different interactive items. Now, for example, we can expand or shrink the timeline using the bottom slider. We can have more traditional ways of selecting query items, like these kind of list-based approaches, binary decisions. Here, should it be push or curse? Of course, nowadays it should be non-binary. And basically, like usual, whatever you select, then the other items will be like a displayed. Where again, very like a typical interactive visualization, which can be taking place in news articles. People are always interested in about names. If you want to see how in 150 years ago, people in the US gave names for their babies. Yeah, you can have this visualization and give a retro name, a really retro name for your baby. Then we have this linking and brushing. And this is also, you have seen this example. This is, I think, the most important technique that one can have. You have 3 or more views, then you basically select one item and the others are changing right away. All right. Let's think the ways we can explore data. We can do that by allowing to see something else. Here we go for cultural heritage practices. So let's see what we can achieve by panning and zooming. We can see that this is a complex phase, but not oversized. Now, a zoomable interface allows you to zoom directly into the details instead of having number of views. It's a very different technique compared, for example, this linking and processing technique that we were showcasing previously. And of course, this requires that the interaction will be super smooth. This is one reminder that we are not talking about the technical requirements of these any of these techniques, but I can say that if you want to implement this kind of pan and zoom interface, it must be super smooth. Because it's not enough that when you zoom, for example, or you pan the canvas, you can always imagine that there's some kind of a big canvas and you are providing like two views, a small viewpoint to that, which is also zoomable. So when you track the canvas pan, basically, you should be able to see sharply everything. We can talk about the terms of refresh rate or something like that, but in practice, we mean that when something moves in, out, or different directions in the canvas, it must be clearly visible during the movement, not only a jump between phases. Otherwise, it's basically unmovable. So this kind of really large, we can take another look. This kind of large visualizations, they look fancy, but well, like I said, they must be smooth. Otherwise, they are like horrible. I can tell as an anecdote that these were super popular at one point of time. We go now back to the golden 90s. Well, what was so golden about 90s? Nothing, basically. But anyway, then we had this kind of, it was first time actually that this kind of like zoomable interfaces became technically possible because of the recent advances in computing technology and especially with graphical displays. And I've been also fascinated. I actually did one of my project works related to zoomable interfaces, and they even plan to have complete operating systems. Well, not complete operating system, but the desktop interface on top of something like Linux, which would be fully based on this pan and zoom principle. Well, that's it. Have you seen it? No, we haven't. But still, quite fancy technique. I like it. Well, very like a simple thing is to allow people to scroll the interface. Here we have again historical like example which shows the connections between royal families. And yes, there were some, even people say that they were too closely connected anyway. Well, this is basically like in previous case, a kind of like a pan zoom interface, except there is no zooming. Instead, we select items, and the visualization then shows connections between the selected item. It can be very handy for this kind of complex things. For example, if you put this into the like a non-zoomable or non-scrollable view, it would be way too much information. So here, this is kind of like a balance between no need for zooming, but still showcasing the individual items so that they are clickable. What is clickable, of course, means what is the precision of the input technique. This is something I really like you to keep in mind. If we are targeting for 28 or 27 inch 4K or even 8K like a monitor, and you have and you don't need to even have a good mouse, but you have a decent mouse, then you are able to select very like precisely. But if you have a 5-inch like a not so super resolution smartphone, and you are using your thumbs to select items, of course, it can't look like this. So, so please keep in mind that some of these techniques, like a scale better to different devices and conditions than some others. So this is also something to keep in mind. And sometimes it might be better to provide alternative technique if you know that the users are using, for example, both PCs and mobile devices. So then we have something called direct walk or direct manipulation. It's basically a way of telling a story. So let's see how it goes. There's the idea that we have here a kind of like a interface for the user to explore. So it's not an animation, but instead we guide the user for the direction that they are liking to see. They have a way to go back and do things at their own pace, and then finish the interaction. Here we have a more animation-based approach. So basically, now we are providing exact animation for the view. And we have a little bit hard time with Kimmo to think of what of these techniques are more suitable for you, because many of you are quite different than our regular students. And I think here, for example, if we have this approach that we can have some of this data visualized and used as a part of like animation inside, let's say, a short film, documentary, whatever. And then you can have like a companion app for the actual production as a web application. You can have a link in the movie or film that just goes there. And then the viewers have the full explorative application for the same data that you showcased as a part of the material. And now they can explore on their own and continue this like experience they are having. And for me, who is interested quite much about like content production. I actually, even I'm a hardcore computer scientist in my education, but before starting my computer science education, I actually studied video and photography, but then I decided to go for the computer background. But I have been thinking since then, and that not much have progressed during these years. We are still watching television as a standalone thing. There were some attempts when the DVD and Blu-ray came that there's additional material, but basically that has died out, I think. And anyway, Blu-rays, physical discs are going away. But there's no interactivity in content production. Even it's 2024. I mean, that's the most amazing thing for me. Why we can't have more interactive media? Why? I mean, I would like to watch myself historical documentation. Most of the stuff I have. Yeah, it would be so interesting to go for the data behind these documentaries. But no, that's basically non-existing. Well, we can change that, I hope. And information visualization offers a lot of tools for that if properly used. And maybe sometime we really see, instead of today's, what I would say, scripted media content, something that can be called as an interactive or non-linear content. All right, I'm recovering my flu. Last week's lecture was quite bad, but I need to pause still a little bit. But now I'm ready to go. So let's look for what we can achieve by reconfiguring things. The data looks like a mess. And now the idea here is that people can basically, or not basically, but in practice, they can try to find out some meaningful clusters out of the data. And one can ask why we can't compute the best possible views. Because if that's doable, let's do it. And usually this kind of like visualizations, this is by the way a little bit messy. Maybe we should select a better example which actually shows some more clearer clusters. But I can say that from computational point of view, there's no, first of all, way to compute all possible solutions and the optical solution, the so-called optimal solutions, because these are hard, complex data problems. So the best candidates are anyway approximations of what would be the very, very best way. And the second thing, there's no usually single like a best view. Instead, depending on what you are looking, you had to select between those and compare those. And that's the whole idea that, I mean, in reorderable matrices like this, they can be fully so that one draws, basically switches the order of columns or rows manually, but also we can use the power of computing to calculate some what the algorithm thinks as a best cases, and then users can browse through those. But still, this kind of things are very much needed, especially in the beginning of the visualization process. As I have been emphasizing many times, and I'm still repeating this, even you might have heard it already many times. We are talking about the process, and in the process, there's typically different tools needed in the beginning when we have no idea what we can get out from this data. We still need this kind of a more low-level approaches to figure out what might be the connecting dots between the data sets, and then we can move up to the higher level or more abstract tools. In this way, this is not typically something that you like to see as an end product, but it's a tool along this path that we are taking, and which is called as the information visualization process. Here's another nice example of how we can explore the data just by rearranging the data items. You just drag and drop, or drag basically different items, and the configuration will be different. This could be really handy in three-dimensional format. There's this extra visualization that might be part of it easily. Then very simple way is to allow manipulation of axes in this kind of two-dimensional visualization. So you can have this kind of like a, here we are talking about years, and now the data changes. Very good for understanding what is in the data items. Then we can go for the encoding part. That basically means that we are encoding the data into different formats to tell a story. This is pretty nice. Please follow the story. You can see these are separating from the data. We're using auto encoding. Now we can see, oh, those are those 4 schools. Okay, this actually I recommend for following this link and exploring this data. There's a more story behind that, and I also like the example because this is something that I can easily see to be embeddable into media products. It's a let's say that if we are having more like emotional audio material content, audio video material content, and then somebody telling the story, then we can have this kind of effective graphics, which definitely show not only the situation at hand, but how it has been evolving, what happened, what the poor choices, for like in this example, for these 5 schools that went out of the like a cycle that everybody else was doing, what happened to them, and it actually continues to compare those for larger than state, I mean, on the country level. Yeah. So this and some of the others, I definitely think that are most like viable for most of your cases. Let's talk about adaptation and elaboration. Here we see where the population of Europe is growing and declining. And we can do this simple by using this zooming technique. So the main point here is that since the data is again much too complex, we had to provide more elaborate view when we zoom in, and then where we making it more abstract when we zoom out. And one can ask, what is difference here with the pan and zoom interface? So basically, if you use the pan and zoom interface, like I said, it displays the information, all information, all the details are here. Just zoom in and out. Of course, the rendering engine hides some things, and it adds those when you go closer. But here you have different level of details. I think this is familiar, for example, from computer games. You have to provide regarding of your viewpoint. You simply have a different kind of representation for the data. So the view is not just closer or far, but there are certain steps. When you zoom in, you change the outlook. And that's the difference for the pan and zoom interface. Can you use the traditional supporting views, hovering items and having a pop-ups, and then you can have additional windows views for providing more data. Again, familiar example. As you can see, there's a huge amount of information. You are providing this kind of ready-made categories, what we eat, how we eat, food skills, food security, and those change the main display. And of course, those additional views on the right side, they reflect to the changes. Now we can have a completely different representation, encoding for the data. Also, this is something that you can explore on your own by following the link and getting ideas how those can be used. Then we have very simple, I would say, special case of zoomable interface to basically jump into the different categories and they automatically became zoomable. Here you can see also the level of detail information that when zoomed out, we don't show the details, but then we start to show those when we drill down on some of the items. And then we go for filtering. This is surprisingly often there are examples of visualizations that are just too complex because they don't allow tools to filter items. Even that's a really simple thing to do. So here's some the complete history of NFL, at least to the year 2020 or something like that. How we can make dynamic queries easily. We have this slider, as you can see, here paste slider. Already in the slider, you are presenting data. So you can see from that, if there's a something phenomena, then you zoom into that, and now you are getting. You should be able to expand and shrink the viewpoint, the upper viewpoint as well. So very, very simple, but effective if you want to. Good for historical data again. Then very simple thing, check boxes. Again, why not use those? Because they are very easy to use. You can see immediately what you want to filter in or include or not. And you don't need a sophisticated interface. Of course, these are usable only when you have a limited amount of things to filter. I think here we have close to the maximum. There's something like 20 items. You can't present 100 or even dream about having that amount of checkboxes. But if you have two hands full of them, they are pretty simple, even smaller screens as well. Again, I'm emphasizing that please do not make it too complicated. If simple checkbox interface allows you to efficiently query and filter the information, why not to use that? All right, let's talk about connecting related items. I think you have seen this already before as well. This is the cultural heritage practices. And the simple thing is that you just show the connections between the items.
Morning in Google.
Hopefully you can then find something that you are looking for. So we end this up by talking about a little bit different alternative interaction methods. Like I said already in the beginning, or at least some point during the discussion, that when we have different input devices, we can have a pen, touch, speech, body gesture, gaze, touch screen, and mouse of course being the most used these days. We have a different accuracy. And of course, this is an independent issue, at least in theory, from the size of the display we are having. But in practice, these often go hand in hand, that you have a larger resolution display with big screens, but not so much, because we already have 4K screens in our smartphones. With 6 inches, and our thumbs are still quite big. So even if you can present the information, you have enough display resolution, your input resolution. Actually, nobody uses thumbs for the interaction, or actually sometimes we use, but the other fingers, and I think pens are actually not so much used those days. They, of course, make more accurate input in small devices as well. But let's say that we are safe if we think of using our index finger for interacting with the mobile devices, and then we use mouse with the PC. And definitely the resolution of input differs quite heavily. Like I said, current mouses are like a super accurate compared, for example, what we can have a freeform in-air gestures if we have a public display interaction with the public displays. Yeah, and of course there are different alternative output devices as well. There could be different other options, specific instruments, sensors, or all kind of fancy things. And we have actually done quite a lot of work in this area in our research projects. At some times it was a very interesting, fascinating to study the possible public displays. We and others who made a lot of work in this area, well, let's say that they have never cocked up. We do have a public displays in here and there, malls, railway stations, airports, just to name a few, but mostly they are either not really interactive, or there's a simple touchscreen interface. We thought for a while that COVID would change this, and people don't want to like a touch anything anymore, but still I think the touchscreen interfaces are the most used. Yeah, but next time we are going to actually see some more fancier examples, talk about extended reality visualizations and things like that. Short introduction to visualization tools. There are a lot of them. This is definitely not any kind of like all-in-one package, but instead let's see some of the ones that we have selected. First of all, we like to talk about importing and exporting data. And I think everybody knows what is comma-separated values, CSV. It's basically like a set of rows, and you have individual data items as separated by comma. Of course, people can use anything else in addition to the comma, as long as it's the same. So for example, if you have this kind of Excel sheet or table, we can like show this as a CSV file like this one, and then it can be imported to any other programs. Excel itself can read quite sophisticatedly, especially if the user helps to interpret different, even damaged CSV files. And of course, Python tools and many, or basically all the information visualization program uses these. I guess everybody needs to do every now and then, play around with these. It's a common data exchange format, widely supported by consumer, business, and scientific applications, yes. And that's much better than some kind of arbitrary data. And we still use that as an immediate format because sometimes it's so used, it would be so convenient to have a CSV as an intermediate format instead of trying to export and import something directly between two programs. But let's talk about two. There's a software called Tableau. It has a public version, which means free, but somehow limited. And it's pretty usable. You can do many of the visualizations that I showcased today and previously last week with Tableau. My own students have been working with this rather heavily. It was the most popular visualization software until 2 years ago. The Microsoft Power BI overruled that. But like I said, it's free. There are numerous import options. You can bring in data from different sources, and especially it has good quality tutorials. And but if you work with the free version, please remember that visualizations are public, so no private data. And it has rather expensive licensing options, but easy one to recommend for newcomers. Then Microsoft Power BI, which is the most used, at least in my own courses. One reason might be that Tampere University, like many universities nowadays, have made the marriage with Microsoft. I would not say that this is a marriage made in heaven, but it's a marriage anyway. And that means that these tools are available for free for the students and teachers. Yeah. Again, it can provide really many views. You can easily create dashboards with these. Google have its own options, and I think that what is really important or interesting is the fact that it works with dynamic content. So I think I was saying in the very early, in the beginning of the this pre-course that we can basically divide information visualization into two categories. First, we have so-called snapshots of data. For example, we are taking data from one starting from beginning of 2020, and the data goes all the way to the 2021. We have 2 years of data, and then we visualize those. And the data is not changing during that time. But many visualizations, especially industrial visualization, for example, require that we are getting live data. For example, in the machinery, there are sensors nowadays equipped with a lot of machinery, and we are getting that data, and we had to process that data and visualize it in real time. And not many tools, especially with the graphical tools, are able to do this kind of like dynamic like a visualization. Google has that. Then, if there's any programmer in you, you can have different JavaScript-based solutions. There are many libraries, and basically, you can do anything you like to do. Some of those are more suitable for beginners. Some require quite a lot of knowledge, and the amount of support you are getting, it depends. Some are made by single people who is definitely not providing any other things than the code. Some have excellent resources. These are one of the JavaScript-based solutions, but basically D3.js is something that has been here for around. Then my favorite is the different Python-based solutions. As you probably know, Python is the most used programming language, and not only so, it has gained popularity compared to any other programming language during the last years. So Python is rising, and others are more or less together dropping. There are, of course, individual differences. Some languages, of course, gain more popularity. Some are more declining. But the trend has been for all programming that Python rules more and more the world. And let's say it's also a nice object-oriented language, unlike you know, some of the tools that say that they are more like beginner friendly, and they are more like tailored towards, for example, creative people. But I can say that that's not the true. They might seem first some other choices like processing, which is quite popular among creative people. They are appealing in the first place, but I would learn if there's one thing that I would do, I would learn the basics of Python. After that, you have the most comprehensive resources in your hand. You can basically do everything. That's because Python is popular. People have made a lot of solutions for that. You simply don't reinvent the wheel, but you just find suitable package, put that into use, and ta-da, there you go. I like to say that Python gives you superpowers. Yeah, I think this is the answer to the question that yes, there are tools which don't require programming, but still I recommend for everybody to learn a little bit Python. That's my humble 5 cents.